Hello, let's talk about section 3.2. We're going to do today solving two-step equations. And notice that when we do two-step equations, the first real step to doing them is identifying what's happening, what's being applied to x in the problem. So in this case, the first thing that's being applied to x is a multiplication, and the second thing is an addition. So it's being multiplied by 3, and it's being added, that product is being added to 7. What can we do to cancel them? Well, we undo a multiplication with division. So we would divide both sides, right? Whatever we do on the left, we have to do on the right. Divide both sides by 3. And adding 7, we undo with subtract 7 from both sides. From both sides. So we use our balance line and we work our order of operations in reverse. Reverse order. Look, it's even in this lovely little box over here. Solving a two-step equation, apply the inverse operations in the reverse order of the order of operations. So we do, instead of doing PEMDAS, please excuse my dear Aunt Sally, when we solve, it becomes SADMEP, right? Another reason why I really don't like that phrase. Remember, additions and subtractions are equal, multiplications and divisions are equal, exponents and parentheses are not. So that, undo that addition. Remember, the additive identity is 0. That's what would get us back to having just a 3x, is if we were adding 0. So if I subtracted 7 on the left of the balance line, I also need to subtract 7 on the right of the balance line. 19 minus 7 is 12. 3 times x, undo with division. Divide, divide, because 3 over 3 is a 1. That's that multiplicative identity. It's going to get us just so we have an x. My balance line is still my equal. Whatever I did on the right, I also have to do on the left, so I have to divide both sides by 3. 12 over 3 is a fraction that I can simplify. It becomes 4. X is equal to 4. Check your work. If you do 3 times 4, that's 12. And 12 plus 7 is 19. Yep, it definitely works. 19 is equal to 19, so check, it works. Makes a true statement. You've got another example here. Operations performed on R, what can we do to cancel them? Operations performed on K, what can we do to cancel them? Work through these, and then come back and check your work. So that hopefully you worked through those problems and you ended up just fine. Notice the zeros and the ones. Zeros and ones. Also notice the list. Divide, subtract, add, multiply. Inverse operations. Multiply, subtract, add, divide. Inverse operations. Let's go to that next page. So now the second type of problem that has two steps is one where on the balance line side, on one side of it, we have like terms, or we have more than one variable on it. So that when we have that happen, we need to combine like terms. Notice that they're on the same side of the balance line, so we're not going to use opposites. We're not going to use inverse operations. 4a plus 3a, we can do that. That is just simply a 7a. That's equal to 63. And now that we have a single variable, we can do our inverse operations to get the variable alone. Divide both sides by 7. Divide by 7. Because that's a 1, so that we get a is equal to 9. Look at the side that the variable is on. Why is this equation different? We have more than one a. What can we do to simplify the side that the variable is on? Combine like terms first. Is the variable alone? Why or why not? What can we do? Our inverse operation then becomes division. Divide both sides by 7. Check your work by substituting that value back in. So if I do 4 times 9 plus 3 times 9 is 36 plus 27. Does that equal 63? 50 and 13, so yes, 63 is the same as 63, so that I did just fine. Would you please work through these example problems? Check your work, and then we'll do story problems. Notice on my second problem, I needed to do some math by hand off to the side. So if you need to do that, do it off to the side. Just stay organized. Let's go down to example 3. Write an equation for the function described. The output of a function is 2 more than 4 times the input. So the output, remember, is always going to be y, and the input will always be x for our class. The output of a function, y, is 2 more than. So remember, that's add 2 to 4 times the input. 4 times the input, that's 4x. So 4x, then add 2. So the second part is using your equation, find the input when the output is 14. Notice the words here, find the input. So we need to find x when the output, y, is 14. So our equation was y equals 4x plus 2. And we need to plug in 14 for y. 14 equals 4x plus 2. Now we can just use our inverse operations. Subtract 2 from both sides. That gives me 12 equals 4x. Divide both sides by 4, which means that 3 is my x value. Use that balance line so that your answers end up nice and organized. You have another checkpoint problem. Give it a try. Alright, so there's your practice problem. Hopefully you did just fine with it. I'm sure you did. I believe that's the end of our notes for today. It is. I'll see you tomorrow for solving multi-step equations.